right, guys, so another quick video. We're talking about, in section 8C, we're talking about real population growth. And right here, you've got a chart kind of showing you what the world population is and how it's grown. And as you notice coming from the left, our values stay pretty low as we're moving through time. So here's about 2,000 years, here's another 2,000 years, here's another 2,000 years, and the population doesn't really grow very much. And then all of a sudden, right about here, things really take a change. And clearly the population starts growing exponentially, very, very quickly. And this is because of a couple of reasons, which we'll get into. But to put the current world population into perspective, here's a few things I want you to keep in mind. And it can be a little bit eye-opening. We all know that the population's growing very quickly, but maybe not the full extent of it. So every 4 years, the world adds nearly as many people to the total population as we have in the United States. So every 4 years, you take all the people in the United States, and that's how many new people there are in the world. Each month, the world population increases by nearly the population of Switzerland. But this is the one that gets me the most. This one really stands out to me. While you study during the next hour and a half, the world population will increase by 10,000 people. So in the next 90 minutes, there are going to be 10,000 more people in the world that need to eat, drink, be clothed, be housed. The population is going to increase by 10,000 people in 90 minutes. And that number right there really kind of puts things into perspective, because that's literally 10,000 more people that need to be fed in the next 90 minutes on top of the people that are already needing to be fed. So this type of growth, obviously it's very exponential. And the biggest reason for this right here, the biggest reason that we went from not a lot of growth to all of a sudden this explosion, the biggest reason that's happening actually has more to do with our death rate. As we've gotten better with medicine, as we've gotten better with keeping people alive, the thing that has changed is the rate at which people die. That has gone down. The rate that we grow hasn't changed much, but the rate that people survive has changed dramatically. So that's why all of a sudden you see this explosion in the population. So example one, and I'm kind of getting ahead of myself a little bit, but it says in 1650, the world population had, let's start over. The average annual growth rate for the world population since 1650 has been about 0.7%. However, the annual rate has varied significantly. It peaked at 2.1% during the 1960s, and currently, as of 2017, the growth rate is 1.1%. Find the approximate doubling time for each of these growth rates. Okay, so I've got three different growth rates here, 0.7%, I've got 2.1%, and then the current 1.1%. So at those rates, remember our approximate doubling time, approximately you take 70 divided by 0.7, and approximately we take 70 divided by 2.1, and approximately 70 divided by 1.1. So if I do the algebra there, if I take 70, let's get rid of some of this, 70 divided by 0.7, that means it's going to take 100 years to double the population. Okay, so at this rate, it's going to take about 100 years to double the population. At 2.1, if I do 70 divided by 2.1, I get about negative 33 years, or negative 33. It's not negative 33. I hit a negative. So we're at about 33 and a third years. And then if I do it by 1.1, 70 divided by 1.1, then I'm looking at about 63 years to double the population, okay? So those numbers aren't that far off. I mean, 0.7% and 1.1% growth, that's a pretty small difference. But when you look at the number of years it takes for the population to double, just that 0.4% makes it take almost twice as long to double. All right. Now, if I wanted to know the world population in 2060 based on the population in 2017. So if I started at 7.5 billion, I'm looking for my new value. And if you remember the formula for last time, we take the new value and we times that by 2 raised to the number of years. So 43 years will have passed. And if my doubling time, let's go with the 1.1%. Let's say that the doubling time is 63. So 7.5 times 2 raised to the 43 over 63. So 7.5 billion times 2 raised to the 43 divided by 63. When I hit enter, that means that in 2060, we would have approximately 12 billion people. So in the next 43 years, I guess that's not 43 years from now, that's 39 years, 40 years from now. In 40 years, we could have 12 billion people on the planet, which is just an insane number of people. Unless COVID turns rampant, and then maybe that'll go down a little bit. I don't know. Overall growth rate. So growth rate, the world population growth rate, is the difference between the birth rate and the death rate. So the amount that we're growing, we take the birth rate and we subtract the people that are dying. So how many are being born minus how many are dying, that's how much we're growing, okay? And for a while, there's parts of the world where their growth rate was actually negative, that they had less people being born than they did people dying in lots of parts of the world. So in 1950, the worldwide birth rate was 37 births per thousand, and the death rate was 37. So the growth rate in 1950 was 37 minus 19, which is 18. So that was the growth rate per thousand. So 18 per thousand people we were growing per year. In 1975, the birth rate fell to 28. So in 1975, my birth rate is now 28, and the death rate is now 11. So my growth rate actually went down a little bit. It went down to 17. So even though our birth rate went down a whole bunch, our death rate, also went down, but not as significantly. So we're still growing, but we're not growing as much as we were. If we look at what's happening, before we were growing at 18 per thousand, now we're only growing at 17. And that's not because a lot less people are being born, it's actually because a lot less people, less people are dying, but more people are not being born. So that gives us that decline in growth rate. Okay? All right, and I guess that sums up 8C. So homework 8C, we're going to stop right there. Just a lot of questions using the growth rate, birth rate, death rate, and a lot of questions about you analyzing why that might happen. So you're going to be looking not just at the growth rate itself, but what's happening with the birth rates and what's happening with the death rates. Okay, if death rates go up, if more people are dying, then your growth rate's going to go down. All right, but if more people are being born, then that's going to make your growth rate go up. So good luck on 8C. Bring your questions to class.